Okay, so in this question,
Oh, wait.
okay, looking up here, please. Okay, so we have a 200-gram toy rocket. What's the trick here? It's got to be in kilograms. Okay, is launched from ground level and reaches a height of 1,600 meters. Initial or final? That's final. What's the initial? 0. Right. Okay, how much work is done? So we're looking for the work. Well, work is a change in what kind of energy in this question? Potential, right. So work will be m times g times h final minus 0 because it started on the ground. All I have to do is go m times g times h. Everybody okay with that? Okay. So that'll be 0.2 times 9.81 times 1,600 meters. Okay, so that's going to be 3,139.2 joules worth of work. Okay. It's quite a bit for a little rocket. Okay. But it is going 1 mile into the air, 1.6 kilometers. Okay, now the second part of this question, how much force does its engine exert? Okay, so we just figured out that this is 3,139.2 joules. Okay, that equals force times distance. What's the distance? 1,600 meters, right. Okay, so I'm going to divide both sides by d. That'll get me the force, which, incidentally, is just going to be m times g, but I'll divide it by 1,600. Okay, 1.962 newtons. So it's not a lot of force, but it happened over a great distance, yeah, okay? That engine was actively pushing for 1.6 kilometers. That's a lot of work. All right, questions on that one? Okay, so this one I actually had on a unit exam about 2 years ago. Okay, give you an idea what kind I might ask. Okay, so definitely unit exam level type of question here. Okay, I have a mass of 0.135 kilograms. Okay, and it's a level floor. If it's level, what's not changing? Height. So this question is about changing kinetic energy. Okay. All right. The rubber band is stretched using 300 newtons worth of force. Okay. Marble starts from rest. Okay, and reaches a speed of 18 meters per second. Okay. How far was the band stretched? So we're looking for D here. Okay, everybody with me so far? All right, so I've got force times distance equals 1/2 mvf squared, and I would write mvi except it's 0, okay, so I don't need to worry about it. All I'm looking for now is D. So what do I have to do with F? Divide it over to the other side. Okay, so D will equal 1/2 times 0.135, the mass of the marble, times VF, which was 18 meters per second, but that has to be squared. Okay, and then divide that by the force, which was 300 newtons. So 0.5 times 0.135 times 18 squared divided by 300. All right, so it was stretched 0.073 meters or 7.3 centimeters. Okay, was the distance it was stretched. Now, when that was on the exam, what do you suppose people's reaction was to getting such a small decimal number? They must have done it wrong. Okay? But what was the problem with that was they didn't think about this is in meters. Okay? You stretch a rubber band, you can only stretch a rubber band so far, okay, before it snaps. So this was not an unreasonable number to get, given the context of the question. And guys, here's something to know about the exam. Your answer, if you do it right, will make sense in the context of the question. I would never have a question that gives an answer that is nonsensical, because that would make you think you had done it wrong. Okay? Like if you did this and you got 2,000 meters, you did something wrong. Okay? You can't stretch a rubber band 2,000 meters. That answer makes no sense. Okay? And it's probably just a matter of punching it in your calculator wrong. But if you understood the context of the question, you'd understand that cannot be the right answer. Okay?
How would you convert that into inches? Because it would make sense if you put it in inches, because it would be like 3 inches or something, right?
Well, yeah, but you'd have to know how many, what is it, 30 some inches in a meter, I don't know what, but we don't use imperial, so, okay, that's why I said, like, you put it in centimeters, that might make more sense.
Yeah.
7.3 centimeters is a number that, you know, about that big. Okay. All right, everybody okay with that? All right, then, I still have to spray down your desks, so we're gonna call it there. Tomorrow we're doing a lab on work, so be ready for that. Okay?